A long, long time ago, back when there used to be stars in my sky, before all the clouds and before the rain, I put out this video here on how to use these small Wyze cameras to monitor my imaging sessions. Whether or not you've watched that video, or whether you have or don't have any of these, you're going to want to watch today because I have an update for you. For those of you that haven't seen the old video, these cheap little cameras allow me to monitor telescopes in real time, create beautiful time lapses of the night sky, and help me understand what's happened or is happening during my session. Whether it's clouds or a cable snag or an animal, or just monitoring a Meridian flip, or maybe just to put eyes on my equipment to get a visual, all with this little Wyze Cam V3. I'm sure many of you who already have one or even 5 of these will agree. This camera is amazing, and the video quality in extreme low light settings, with or without IR enabled, is just fantastic. I'm not going to revisit all of the camera capabilities like local 24/7 recording. You can just watch the old video for that. But in the previous video, I did focus on one experimental feature that unfortunately got dropped by Wyze: the capability to stream video via RTSP. The RTSP capability in that experimental firmware turned out to be so popular that a lot of us jumped on board and picked up a couple of these cameras. Then Stefan, the creator of Nina, decided to create an RTSP streaming plugin, which gave us the ability to view our camera directly on Nina's imaging page. As a result, we could monitor our imaging sessions and also a live view of our telescope on the same page at the same time. Well, as I mentioned, Wyze stopped development of the RTSP feature, probably because it wasn't great for their business model. But good news, today, I'm going to show you a way to get RTSP back on these cameras, along with a bunch of other really cool capabilities, all without losing access to the camera or any existing features within the Wyze mobile application. I'll even give you a bonus today if you stick around until the end. I'll show you how you can even live stream your Wyze camera feed to YouTube, Facebook, or Twitch directly from the camera. And of course, if you've been watching me for a while, you know that I'll show you how to do it with step-by-step instructions. Ready? Hey everybody, in case we haven't met yet, I'm Chad, or Patriot Astro, and it's time for me to show you some software you might want to pair with your Wyze cameras. The solution we're looking at today is WZ Mini Hacks on GitHub. And before you run over there, since I recorded this video in the last couple days, the README page and wiki for the project have been modified already. It's basically the same information, but reorganized a bit. It'll look a little different by the time you get there. Just click the wiki menu option and you'll find everything you need. So what is this all about? This is some additional software you can run directly on your Wyze cameras while still maintaining the same capabilities the camera already has today, including using it just like you already do in your mobile or web application. Basically, we're going to add some additional capabilities to your already great Wyze cameras. You do need to have a supported camera model, which is in this list here. And here's a couple more important warnings. This is not supported by Wyze. Don't call them for help. This is free software downloaded from GitHub on the internet. So realize there is always some risk, up to and including the potential of you bricking your camera. I've personally installed this several times now on multiple cameras using the process I'm about to teach you, and I've had no issues, but still there is risk, and this is your responsibility. It is only a $30 camera, but money is money. Now, software features. What can this do? A lot, actually. First, you need to understand that it doesn't alter the camera's file system. If you want to remove the software, just remove and format the micro SD card, then reboot it. That's it. The camera will keep working in the Wyze app, no problem. Because the Wyze firmware continues to run, we need a supported version of the Wyze firmware on this camera. You can run almost any version of the firmware on the camera, and this will work. But there is one caveat. If you want RTSP streaming, and we do, you need to run a specific version of the Wyze firmware or lower. Don't worry, I'll help you with that part later. Now, the actual feature list. This software supports WireGuard. This is a VPN tunneling mechanism that allows you to encrypt your video streams and even tunnel them back to a remote location. And in case you're already familiar with WireGuard, the project creator has tested it with Tailscale, which allows you to dynamically access your cameras and endpoints securely anywhere at any time. Some of you with remote equipment may want to consider this. You know how your Wyze Cam 3 is Wi-Fi only? Well, maybe not anymore. This project allows you to connect a supported USB Ethernet adapter. Some of those models may allow you to use power over Ethernet to power the device. Others will have a separate power brick. Your cameras can now use Ethernet instead of Wi-Fi. MiniHacks also enables USB gadget support. This means you can connect the camera via USB to supported home routers to get an internet connection via their USB cable. Once again, no Wi-Fi needed. And since the camera is running a shell, you can even run some custom scripts if you like. I've already mentioned that it supports RTSP streaming, and we'll be configuring that shortly. If you happen to have an Android phone, you can tether the camera directly to it. Of course, the data charges are your responsibility. You can even access USB mass storage now, mount external drives, and even CIFS is supported. It supports IP tables to secure the local network connection. You can even play custom WAV files directly from the camera. And if you like, because you have an extra one laying around, you can turn this into a webcam. Even RTMP is supported, so now you can live stream from the camera directly to YouTube, Twitch, or Facebook. And one last feature that's hiding way down the README page because it's advanced and takes some work, and I'll let you hunt this one down on your own, but it's called self-hosted or isolated mode, meaning you can remove this camera from the Wyze app and run it without the dependency. So will you need all of these capabilities? No, probably not, but a couple of these are really nice, and RTSP is the first one we'll look at. Everything I show you today is using one of my own Wyze Cam V3s. Feel free to follow along and pause the video if needed. Let's start by looking at the step-by-step installation. There's one step missing for our use case of enabling RTSP. Remember that for RTSP, our camera installed firmware cannot be higher than version 4.36.9.139. Using that version will put us a couple firmware revisions behind, but I haven't had any problems running it. I already have my camera online here, but you may pull yours out of the box brand new. It really doesn't matter how you start. But first, we need to make sure we get the right firmware on the camera. And where do you get the camera firmware? Directly from Wyze. Search online for Wyze Cam firmware and locate this support.wyze.com release notes and firmware page. Then select cameras and select your camera. Then for RTSP support, we don't want to go past .139. Unfortunately, because I already have a newer firmware installed, what I found from doing this multiple times is that we're gonna have to do this in 2 steps. It's easy, but a bit repetitive. Let's download both 4.36.9.139 and 4.36.9.131. Then go to our downloads folder, extract both, and delete the original zip files. Okay, let's chat for a second. You need a micro SD card now. You can use the one you may already have in your camera or a new one if you like. While it can be a small card of 32 gig or less, I prefer to use larger 128 or 256 gig cards, so I have lots of available storage for recorded videos. I'll of course put affiliate-based links to everything I'm using, plus any other important links within the video description below. Remember, affiliate links mean I may be compensated at no cost to you. They make me say that. Back to the cards. There's a requirement within this project that states we need to format the micro SD card used in our camera as FAT32. This is so the bootloader can work. If you format the card in the camera using the Wyze mobile app, it's going to use exFAT. And if you try to use Windows really does not want to format anything larger than 32 gig as FAT32 and will force you to use exFAT. So how are we going to do this? There's several different ways to go about it, but I'm going to show you the easiest by far. Believe it or not, go download the Raspberry Pi Imager software. It's lightweight and easy to use. Install it and then open it up. I already have mine installed here. Now go ahead and insert your micro SD card into the computer and make sure that it shows up in the file system. If you get a warning, click on it and tell it to continue without scanning. Also pay attention to the drive letter if possible. It'll help in a minute. Mine is drive I right now. In the Pi Imager software, click Choose OS. We are not installing an operating system, but you can scroll down and select Erase. This will erase the micro SD card and format it for us as FAT32. Next, click Choose Storage. You have to triple check what you're doing here, and then maybe check it 2 more times. Make sure you're selecting the micro SD card and nothing else. You can erase your operating system and wipe out your machine. Be careful. Then, when ready, click Write to proceed. It will quickly erase and format the card as FAT32. Now locate the version 131 firmware file in your downloads. It will be the bin file. Copy it, then open the SD card, which may have changed drive letters after the format, and then paste it in here. Now properly eject the micro SD card from the operating system and insert it into your powered off camera. In order to install this firmware on your camera, you need to press and hold the setup button on the camera while connecting the device to power. Keep pressing the setup button while watching the light on the front of the camera. Once the light turns purplish, you can let go of the setup button. Now wait. Eventually, the light will turn red, and then maybe wait a few more seconds just in case. Now unplug the camera power and remove the SD card from the camera and put it back into your computer. We are now flashed up to version 131, but we need to get to version 139. So go back into the Pi Imager software again and reformat this same card as FAT32 one more time. Be careful, select the right SD card as the drive to format. After formatting, copy the firmware version 139 bin file to the card and then eject it properly from Windows. Put the card back into the camera and hold the setup button while reconnecting it to power again. Wait for the color of the LED to turn purple and then release the button. And once again, wait for the firmware to finish with a reboot and finally the red light at the end. At this point, we can leave the camera powered on and also add the camera to our Wyze account on the mobile app. To do this, we'll open the Wyze app on your phone and press the plus button, then add device, select cameras, and the camera type. My camera's already powered on, so I can click next. It will ask me to press the setup button on the camera, which I will do. And then once I hear that it's ready to connect, I can click next. Your app should already know about your Wi-Fi, so you can proceed, and then it will generate a QR code to register this camera into your account. Point your camera at the QR code on your phone, and you should hear QR code scanned.
QR code scanned. Please wait.
Click the checkbox and next. Wait for it to be added to the account. Name it and complete any additional prompts. Once added, let's verify video and also check the installed firmware version to verify we're running 139. Perfect. We're finally ready to work with the WZ Mini Hacks software. Let's go back to the GitHub project webpage. Now download the repo as a zip file and extract it to your file system. Depending on your operating system, you may already have a text editor in place that'll work, but for anyone using Windows, I'm going to recommend installing Notepad++. You can download it from here and then run through the simple installation. I already have mine installed. Not all text editors are created equal. Notice that this application and a lot of other text applications may default to different line ending types, which right now here is Windows-based. We want to change it to Unix LF, otherwise you may run into an issue later. Anytime you edit a file today, please double check this is set to Unix LF. Let's open the primary configuration file for the project. It's in the downloaded project folder with an SD root, WZ Mini, and is this conf file here. In this file, we'll change a couple things. First, modify the host name. The name you type isn't important and doesn't need to match what you set in the Wyze app. Then come down to the video stream section and set a name and password. I'll use Astro. Next, I'll only configure the high resolution video because I really have no need for low resolution video. I'll change both high res options to true. Now head down to the general section and I'm going to change the night drop disable setting to true so that the camera doesn't drop my frame rate when it's a low light environment, which is actually a Wyze Camera default action. You could also change disable firmware upgrade to true here, but I'll do that later. This feature could protect you from inadvertently getting a newer firmware upgrade installed that would prevent RTSP from working later on. Finally, go to the web section and enable the web server by setting it to true and also configuring the login name and password. And that's it. Let's save this file. We did just enable a web interface, but there's going to be a lot of times that I'll recommend using SSH command line access instead because it seems to be a little bit cleaner. To get SSH working on here, the project requires SSH public key authentication. Let me show you how to set that up. Here in Windows, I'll open a command line using CMD and then I'll run SSH-keygen. Press enter through these options, and in my particular case, it already existed because I've already done this before. So I'll just go ahead and say yes, but you likely won't see this prompt. Remember, don't type anything, just press enter for each option. Once that's done, we need to move the public key we just created into place for our camera. And to do that, we'll go back into Notepad++ and open the public key file. It's on the C drive in Users, then find your user account for Windows, and the .ssh folder. Now locate the ID_RSA file, but specifically the one that says public key or publisher or has the P icon on it here. This is our public key. Open it and copy all of this text, making sure Unix LF is still enabled. Now let's open another file from the project repository. In sdroot wzmini etc ssh, open this authorized keys file. Paste the copied text in here, again making sure Unix LF is set. Now save this file and close it. Basically, we just generated a public key that identifies our Windows system and put it into the SSH authorized key file that we're going to move to the Wyze Camera. This allows us to access the Wyze Camera via SSH from this particular Windows system very easily. You'd need to repeat this process if you have other systems that would like to access the camera via SSH. At this point, we've finished our basic configuration, and now we can finally copy it all over to our Wyze Camera. Go ahead and power off your camera and remove the micro SD card. Put it back into our Windows computer, and you guessed it, we have to yet again use PyImager to reformat the card. Yes, again. Make sure you format the right drive. This is getting repetitive and it's no time to get lazy and select the wrong drive. You could have a very, very, very bad day. Once the SD card is erased again and formatted to FAT32, we're going to copy everything inside of that SD root folder to the reformatted micro SD card, and once it's done copying, we can properly eject it from the Windows system and once again insert it back into our camera one last time. Now you can power up the camera and let it boot. If we listen, as it boots, we'll hear some prompts the first time it boots up.
WZ-Mini, initializing first boot.
You should have heard it first tell you that it was initializing first boot.
Extracting swap, please wait.
And then that it was extracting swap, please wait. That's the install process. The worst part's the firmware. The rest is pretty simple. Before we can test it out, we need to know where the Wyze Camera is on our home Wi-Fi network by IP address. To do that, you should first get the MAC address of your camera by looking inside your Wyze mobile app at the camera's device info settings page, or just flip over your camera and get the MAC address printed on the base. This part here of assigning a specific IP address or reservation in your home Wi-Fi router will vary by manufacturer. Your best bet is to Google your router model and DHCP reservation to find the workflow to complete this process. For me, I use an Eero system, so I'll open the Eero app on my phone to find the camera and reserve it an IP address. We do this so it has the same IP address after every reboot, and in my case, Eero makes this easy. Now this camera will always be assigned 192.168.4.125 on my home network. All right, let's go into Nina and test this out. If you don't have the RTSP client plugin installed, go ahead and add it now, and then restart Nina. Once it's ready, go to the imaging page and find the RTSP player window. Click up here to enable or disable it. Tell the plugin where the RTSP stream is located. In my case, I have Astro and Astro for the authentication up front, and then 192.168.4.125:8554/. Then this last part after the slash is actually in the documentation from earlier. If you enabled both high-res and low-res streams, you need to use one of these keywords. For us, with only a single high-res stream enabled, we can just type unicast. And then I click play, and there you go. I can now point this camera at my telescope and monitor it throughout a session while I'm also watching my imaging roll on in. I can even move it over here to make it a little bit smaller and get it out of the way. So great, RTSP is working, but I still want to show you the web server interface and SSH access because you might need those at some point. To go to the web server, just open a browser and connect to the IP address of the camera. Log in using the credentials you set earlier, and click the Configuration Editor link to see all of the configuration options we configured earlier in Notepad++. I do like this web interface, but have found SSH configuration of the files to be more consistent So let me show you SSH access now. Open the command shell and type SSH root @ your camera IP address. You can use other SSH client software if you like, but I'll use Windows 11 command line today to keep it simple for everyone. Assuming that you properly moved your public key to the camera, you should get right in. The first time you access it though, it'll prompt you about the connection. You can just type yes. Now we can check the present working directory with a pwd command to see where we are, which is root as you can see by the /. We can also see a directory listing by typing ls. I also want to show you the configuration file in case you ever need it. And to do this, we'll use the built-in nano editor by typing nano/opt/wc_mini/wz_mini.conf. You can make edits here if necessary, and when you're done, press Ctrl+X, and if you've made a modification, it will ask you if you want to save it and if you want to use the same file name. Otherwise, it'll just exit if you haven't made any changes. So let's get out of there and then exit SSH. It should be noted that even though RTSP is running, we can still access the camera in the mobile app and watch it that way as well. Simultaneously to RTSP connections, no problem. Full functionality is still available while the stream is running. And now you've got a great view of your telescope or whatever you want to watch directly from Nina. For some of you, that may be enough, but I did promise to show you how you can also enable another protocol, RTMP, which supports live streaming directly from the camera to YouTube, Twitch, or even Facebook. Today I'll quickly show you how I can live stream to my YouTube channel from my Wyze Camera. As I mentioned earlier, I prefer command line, so I'll go ahead and connect to the camera again via SSH. Let's edit the configuration file. These are changes I needed for RTMP to work with YouTube. If you're going to use one of the other services, you may or may not need similar edits. I'm going to hardcode some settings for video 0, which is the high-res feed. We're going to set the maximum bitrate to 4096, the target bitrate to 2048, the encoder parameter to 2, and frames per second to 20. I'll change RTMP stream enabled to true, and I'll set it to use the unicast feed. I also have to add my YouTube live stream key here, but I won't show you that. I'm also not going to be able to teach you everything about live streaming on these services today, but I'll show you how it works. Once done in here, I can save the updated configuration file. There is one more file I found I needed to edit though. I'm going to use Nano again to open rtmp-stream.sh. This is the script that kicks off the live stream, and I need to make some subtle modifications. See, in my YouTube live stream interface, it told me I needed to stream to a.rtmp, not b.rtmp, so I need to edit that. And I also need to modify the video options to add a couple settings so that I don't get some complaints in the YouTube interface. Here I'll add max interleave delta 0 and video size 1920 by 1080. Then I'll Ctrl+X and save it. Okay, now we can reboot this camera and go to my YouTube live feed management page and watch and wait for the camera to come back online. And there you go. My camera is now available in the mobile application, recording full time to the local micro SD card, potentially creating a time lapse, streaming RTSP to Nina, and also live streaming to my YouTube channel all by itself without any other software or systems on my network. So, what do you think? Pretty powerful stuff, right? These little cameras are amazing, and I cannot say that enough. At the price point, the camera itself, without adding WZ mini hacks, is worth it. But the ability to get a stream onto the Nina imaging page, and then potentially live stream too, just takes it to another level. Maybe we can visit some of the other capabilities in this code down the road, but that's enough for today. Reach out if you have any questions, and don't forget to look at the documentation and wiki pages on the GitHub project. You can reach me at my email address on Instagram and in various other forums online, and of course in the comments. I love reading your comments. I've got some more interesting stuff coming, and maybe even some things related to the use of this camera, so keep watching. Get your cameras running, and as always, clear skies.